right, so we're in the time series module and we're moving into the data acquisition section. And I want to share with you now what we're doing in this data acquisition session is not specifically keyed into time series. So far, y'all have acquired all kinds of data. You've acquired data straight from a CSV file. You've acquired data from Excel files. You've acquired data from databases, from the SQL database, right? Now, in this lesson, we're going to introduce how to get data from an API. And I'll explain what an API is, how we get data from them. And again, this isn't specific just to time series, but you'll notice as we go through different modules, we introduce new ways of acquiring data. Because if we just did it all at once, it'd be overwhelming, right? So for this lesson, our main focus is getting data from a REST API. That doesn't mean it's falling asleep on the job. REST stands for Representational State Transfer. That's a really fancy way of saying getting data from one web application or one application to another, right? So I'll give you a little example. We're used to seeing data on the web in the form of web pages, right? Or even applications that work inside of a web page, like Grubhub or something like that, right? And we're used to seeing CSV files, but consider, I don't know if y'all have seen this one before. I have a random quote generator. This site aphorisms.glitch.me, and looking at what it's returning here, what does that look like to y'all? What kind of data type does that look like?
Dictionary.
Looks like a dictionary. It's a JSON also. JSON syntax is also a dictionary or a list of dictionaries. Yeah, so this is not a web page, right? This in fact is an API. It's just giving us data. So API is short for Application Program Interface. What the heck does that mean? That means we're getting data from one application to another program. Okay, so lots of sites will actually make data available through an API. GitHub does this, so you don't have to click through pages on GitHub. You can just make requests straight to the API. My little quotes application is an example here. There's even something called the Star Wars API. There's thousands and thousands and thousands of APIs out there. So the Star Wars API, if you put in the inside of your URL, API/people/1, really APIs are about sending requests and getting data back. So when I look at the first page, it's Luke Skywalker. And look at that. What kind of data type does this look like to y'all?
JSON. Looks like JSON.
Yeah, it's totally JSON, which is also, it happens to be either a dictionary or a list of dictionaries. That's valid JSON, is a dictionary or a list of dictionaries. It's just a wonderful, happy coincidence that JavaScript object notation matches Python dictionary notation. In fact, they're used in almost identically the same ways, data transfer.
Is it a coincidence?
I want to say it is a coincidence, yeah.
Awesome.
I could be wrong, but we'll do the history of programming languages another time.
Sure.
Okay, so by sending different parts of the URL, I can get different information back. So we have this pattern, people/2, and we see this is C3PO. All right, we can zoom in and notice we see this is a little nice to have in APIs. See how C3PO is referenced in these other films here? If we were to pull up one of these films, see how that URL is different, film/1 as opposed to people. When I plug films in there, I get the movie, it's A New Hope. And it has the list of all the characters, has a list of all the planets represented in that movie, list of all the starships, all the vehicles, all the species. Okay, so think of APIs as a way of getting at database contents, right? But not everybody wants to give you the keys to their database, right? And what's really nice about sending JSON is not the only thing you can send through an API, but it is the world's most popular data interchange format at this point. When we send JSON through an API, what we're doing is we don't have to care if the Star Wars API is written in Ruby or Python or C#. We're not talking any of that code. What the code that to request data, we form the URL a certain way. Like if I goof up the formatting, I'm going to get a page not found error, right? But if you write your requests such that you're conforming to that API's surface, is what we call it, like the URLs that it pays attention to, we don't have to pay attention to or even care about how the site was written. So that's really nice. It allows us to talk to other programs without writing that program's programming language, because it's just made data available to us. It's really awesome stuff. So not all REST APIs give us JSON. Some might give us XML, some might give us plain text, just text back. But by and large, almost all the time, you're going to see JSON, almost all the time, coming from an API. Okay. So some of the data structures that we get back are from a REST API. If it gives us back JSON, we either get back a dictionary or a list of dictionaries. And that's really, really cool stuff. Let's see, I'm going to fire up a notebook here. And yeah, content, time series. And I'm going to pull up the exact notebook from the curriculum. So the notebook that I'm showing y'all is not different than the curriculum. I want to be able to run things for y'all, however. So you can certainly read more on REST. Really, all REST is, and APIs are doing, is mapping URL patterns. And they're different for every server, right? The Star Wars API is different than my quotes API. So URL patterns give us JSON. And we can rock and roll with JSON because it's dictionaries or lists of dictionaries, right? And if you have a list of dictionaries, well, by gum, you can turn that into a data frame, can't you? Right? So here's a super simple example. A list of dictionaries, right? We know we have a list with square brackets, and then each dictionary is curly braces with a key and a value. And there might be nesting within inside of that. Lots of nested data structures in the world. Okay, so how do we start talking across the internet with Python? Well, the tools that y'all have already been using, you've managed to read CSVs, you've read Excel files, and you've read from SQL databases, made requests from SQL databases. There is another base Python library called requests. And requests are how we talk about making requests over the web, how the whole dang internet works, right? Clients, like a browser. When you go in your browser to google.com, google.com is the server, your browser is the client. Your client sends a request to the server sends data back if it can, okay? So what we're doing with this requests library here is we're using Python basically like our browser in so many words, right? It's not going to run JavaScript. It's not going to render anything. There's nothing visual here. But check this out. What this requests library gets us back is the ability to make a request, an HTTP request across the internet. And if that server's there, and if there's any authentication, if you've figured that out, everything we're going to be using doesn't require additional authentication. But check this out. I'm going to make a request and a GET request. In the anatomy of requests, there's GET requests, which is a download request. It's a gimme request. And then there's a post, and a post is an upload. And we're not going to do any uploading with the request library. Places where you would have seen post requests is in an HTML form when you're filling out a form. You're sending data, you're posting up data rather than downloading. Okay, so check this out. This request.get, get and post are the two kinds of request methods browsers can talk. And notice I'm sending this to URL. Now, this particular URL, the way it's built underneath the hood is to randomize a quote from my little quotes JSON file. And we get back this response object. And we would print out the response object itself. It says 200 here, which is good. If it said 404, what do y'all think 404 on the request might mean?
Not found.
Yeah, not found. Yeah, not found. There's some other responses we might get back, like a 500 error if something's wrong with the server. So once we have this response object, check this out, we can access a couple of different methods on it. We won't use all of these, right? But if there's JSON, we can talk to the JSON on that request. Okay, is the status okay or not? We can look at the raw request back, the status code, the URL, all sorts of cool stuff. So let's take a look at what we're going to use 90% of the time. Response okay, that's a Boolean that tells you if the response is okay or not. If there was any kind of error, this isn't telling you what the error is, just if it came back okay. The status code is what's called an HTTP status code. You usually don't see 200 because an HTTP status code of 200 means, oh, here you go. When something has an HTTP status code of 200 on the web, like I'm visiting that same URL pattern, it just comes back. It just sends you what you need. Some things y'all might have seen though is like a 404, page not found, 403 forbidden, like you have to authenticate first, 500 level errors if something's wrong with the server, maybe a 300 level error, or not an error, but a 300 level status code if there's a redirect. Anybody ever see a 300 HTTP? No, that's okay. So this response object can give us back text. And I'm going to show you all a little something. Right now I'm using response to read what's JSON, right? Isn't this a little weird? We have a dictionary, which is valid JSON, inside of a string. So that's kind of nested. We should probably, instead of, if we know we're getting back JSON, we can do .json, friends, and get back the JSON. So if you have a dictionary, a single object, this will come back as a single dictionary. If you have a list of dictionaries, this will come back as a list object or a list data type. And that's pretty cool. Now check this out. Let's see, what if we sent a request to something that's not an API, just a plain old web page, github.com. Takes just a second. Request. Oh, it's request plural, excuse my typo. So this request would not work. It would not function if my Wi-Fi was turned off, right? Because we're going across the whole dang internet. And check out what's behind this response text. That's all the HTML on GitHub's homepage. So a preview of coming attractions, we're gonna revisit our good friend response, who I'm just introducing y'all to now. We're gonna use these request library in order to scrape web pages and get web page content. That'll be a future data acquisition lesson. Because sometimes what you want to find is not in a database, it's not in a spreadsheet, it's not in a CSV, it's not even behind an API. You want to scrape product prices for a competitor maybe. Right? So we'll be using this request library to hit web pages later. For now, we're going to stick to JSON, okay? But if you take a look at that response text, it's literally the same thing as if you looked at the source code. With view source, new line, new line, new line, doc type HTML, HTML language is English, Do line to line to line, doc type, HTML, HTML language, English. Pretty cool, huh? I'm going to clean that off of our notebook and add a little comment here that says, send requests to web pages too. That's pretty awesome. I'm going to pause real quick and prompt you all for any clarification questions so far. I've introduced a couple of new vocabulary terms, a request and a response. Think of a web server kind of like a waiter, right? You request something from a waiter, the waiter brings you what you requested or tells you that there was a problem, right? Lori, go ahead.
So I see kind of the difference between the response.txt and the response.json.
Yeah.
Included in this term.
Yeah.
But so when would I use one or the other?
Yeah, the quick answer is if you know you're getting raw text from a page, then say use .text. And you'll also use .text if you want to get at the HTML of a web page. But if you see curly braces or square brackets containing curly braces, then use JSON. It's basically your if this, then that. So you don't always have to know what the data type is. I mean, it helps to check it out in a browser. But usually if you're getting back anything from an API, you'll use the .json method. And I'll give you all another example on that.
Ryan, you do have a question in the Zoom.
Oh, do I? Oh, thank you. Yeah, go ahead, Brian.
Do you want to answer Jeanette's question first? We're going to go off on a tangent.
A tiny tangent, but you're not going to distract me.
Okay, well, my question then is what you're making me think of, we can access the HTML. And I'm thinking of the scenario where, like, imagine I have a web page. It's actually not even you have to imagine. I have a web page that I want to go and download CSVs automatically. And I'm wondering if we're going to get to be able to see some acquisition where we're able to do that, like automatically on a certain day and time, generate the CSV off the web page and download it.
Oh, sure. Let's see. So this web page that you're talking about, does it have the links to the CSV files for download?
It's a website where you just fill in a couple of fields, like, you know, for what you want, and click download a CSV, and you just get a little, it's not even a big file, it's rather small, but you just, it downloads according to the fields you filled in.
Okay. If we are so lucky, we might not be so lucky, that web page might allow us to do a post request. And then in the post request data, we fill out the values that we want to fill in the form. But I can't promise you that site is set up to work that way. I didn't build it. Yeah, something that also might be pretty common that you'll see is a web page with lists, with like a list of CSV links. Have y'all ever seen that in a data set somewhere? It's a web page that says, this is the data that we have for whatever. Here's a bunch of CSVs. Yeah, you can scrape that web page and get the URLs for all those CSVs and download them all as well. Because it's just a loop, it's just a list of strings on the web page, ultimately. I'm getting a little ahead of myself though. We'll get into web scraping when we get into web scraping. I'm going to show y'all, I will go on another tangent. Remember aphorisms, glitch.me, behind a different part of the URL called /API/all. This is every quote in my little quote generator. So looking at this with response.txt, if I see the single quote here, and then I see a square bracket and curlies for the dictionary, this is my if this then that trigger for saying, oh, okay, this is JSON. I'm just going to use JSON. So when we use the JSON function here, we have a list of dictionaries. And the fact about this quotes generator, y'all, this is something I wrote in Node. Like nowhere in here do we have to write any JavaScript. We just send an API. We just send the API request to the right URL. We get data back. Really cool, clean way to get data.
Is the API slash all, is that unique to your page or is that?
It is unique to my page, but you'll start to notice patterns between different APIs. Yeah. You might see patterns with pagination or like in that Star Wars API, you plug in a piece of a variable basically, and it gives you back stuff. Yeah, it's really cool. But there's not a single pattern for every API out there, sadly.
And is that information you just Google like API for this website and find it?
Yeah. Yeah, it's not too crazy. I'll give you all, let's see if I can remember the yeah, there you go. And usually you're gonna find documentation. If there's not documentation, they should be a little more professional, and that's not on you. But here's an example of the GitHub API. So api.github.com/user/a username, you can get information back about that user. Pretty cool, huh? And inside of this, there are other URLs that are giving us access to another corner of that API. If I wanted a list of all of my repositories, because this is basically my profile, if I wanted to look at all of the repositories, we change the URL. It's all about the URL pattern. URL pattern gives you what you're looking for. You don't have a typo, and if you have all the right rights. So this is a list of all the different repositories I've built. And you can plug this in for any other user. So that's pretty cool. And if you want to know more about the GitHub API, you can check it out. Okay. So let's look at another example. The Star Wars API has different pieces of the URL that you can use. You could use people, films, starships, planets. It's pretty cool. And then after that, there's a number, right? So let's see what the fifth person to show up in Star Wars was. I think these are pretty, yeah, I think these are pretty chronological.
I think for display was 49 kilos.
Okay. So that's not too shabby, and you can change parts of the URL and get different results. Uncle Owen, right?
Is there a reason you put it in a print statement this time?
No.
Okay.
See what the 100th person is. Not found. There's not that many characters apparently.
Oh, stormtroopers.
There we go. I have no idea who Ben is there.
I think that's a pod racer actually in the first film.
Ooh,
Yeah, he's a pod racer. He's got 4 engines on his pod racer.
there you go. Gascon.
Also,
sounds like a
also
pod
pod
racer.
racer.
Mhm.
So Boba kind of drove. I'm gonna stop there.
Yeah.
Really showing your true colors.
So we're sending requests to a URL. And if our request conforms to basically the servers have a whole bunch of if this, then that logic. That's really all that we need to worry about is making sure that our URL pattern matches how the API is built. And the Star Wars API, as you know, however much of a Star Wars fan you are, I am a huge fan of the documentation for this because it kind of lets you play with it in the browser first before using it. It's nice to find documentation for APIs that's beginner friendly. Not all documentation is necessarily beginner friendly, but this one is very beginner friendly. Okay. Let's see what else we can start working with. We have another API set up for y'all. It's called python.zgouldy.net. This is a site maintained by Zach Gouldy. He's teaching on the 3rd floor right now. And when we send a request to the base URL here, this is a really good example of API documentation. This tells us that the API itself, look at the keys we have. We have a key called API, and we have a key called help. It would stand to reason that if we need help, we go to that URL with /documentation at the end. And if we want to talk to the API at all, we slash API slash v1. Conceivably, you might, depending on how long you use an API, you might see a v2 or a v3, something like that, right? So let's see what happens when we take the python.zgoldie.net/documentation. Let's take a look at what we get back here. What we get back is a piece of JSON, and I'm going to take the print out of there and the payload. So the JSON comes back. It's a little hairy in here, right? That's why we're printing just the payload string. The API accepts GET requests. That's a download request for all endpoints where the endpoints are prefixed with /API. And then in API docs, you're going to see curly braces around something that's a variable. And this is the same thing in GitHub API. So this isn't some stuff that Zach made up, this notation of putting curly braces. You'll see under some of these URLs, there's curly braces around another piece of the URL for the API that's a variable. That's a pretty good standard, okay? So if I want to see what repos I've starred, /starred, / who the owner is, / who the repo owner is. So those are variables too. So this tells us here's how to use the API, API/version. This will be version 1. And then here are some of the endpoints we have. Endpoints is the part of the URL that's not the base, basically. And so /stores gives us store information, /items, and /sales. So we'll be doing our exercises using this API here. It's got a bunch of good stuff. So
Where did the payload string come from?
yeah, good question. So the payload is coming from the JSON. And let's take a look at our JSON in isolation. There's a payload string. It is one of our keys. And there's another key called status. So we already know that the status is okay. So there really isn't anything else on this response object other than if we were to do, I think .keys is a function. Yeah, there's only 2 keys, payload and status. Other APIs may give you back a differently named key. They might say content or body or something like that. So that's variable based on how the developer on that API built things. Yeah.
Sorry, I'm just trying to get my bearings from coming in from my meeting with Stephen.
Yeah, yeah.
Is this the data acquisition of time series of the curriculum? Is that where we're at?
Yeah, data acquisition, and the notebook that I'm running is identical to the one in the curriculum. I'm not running on some different notebook right now.
Outstanding, thank you.
Cool. And the question that Stephanie asked was a real good one. Where did the key come from? So if I check this out, I could check out the status key. That should tell me it's okay. But then payload, that's where we get the actual content of the documentation. So how we would use this documentation, we know we need to start with the base URL, add /API. The documentation tells us that the version is v1. And then we can add on /stores to get store information, items to get item information, or sales to get sale information. And notice something else in the docs here, these endpoints here. We don't have to send in a specific store ID, but we could. See how the bracket comes before that next slash, comes before the variable? It's a way of saying this is optional. So let's see what happens when we send in this entire object. And we'll just take a look at the keys first. So I'm sending a request to say list all of the items. There's a status key. Now the good news is that the status is okay because we got something back, but we still need to dig into this payload. So when we look into the payload, data bracket quote payload, here are the keys we have. We have items, next page, page, and previous page. So this would stand to reason. Items gives us a list of items at actually all items, right? And then the max page, next page, current page, and previous page, that's indicating that there's more results than this is going to send us back at once. So let's take a peek at this payload on its own. The data variable, all that is holding the response.json. Okay. We'll take a look at the payload. And this is a pretty large payload. This is, see how we have a dictionary listing items. And then the value for items is a list of dictionaries. So we have some rice, some sort of moisturizing bar, yogurt, cheese, rice crackers. This all looks like a whole bunch of like grocery store products, right? Plums, combs, mounting squares, refried beans, whatever. The other keys we have in here is the maximum page. This is telling us how many more pages, what's the highest number of page? What is the URL for the next page? See how this endpoint says /API/v2/items (page equals 2. So this is telling us how to navigate to the very next page. Page tells us what current page number we're on. And if we're on page 1, the previous page is none. That makes sense. There's no previous page to the first page results. And you'll see paginated results in API results, just like you see paginated results on a web page. Because if you look for shoes on Zappos, it's not going to send you 1,000,000 shoes back. It's going to send you back like 50 or 100, and then you can cycle through the pages. Question, Lori?
Yes, so I guess I had a little bit of trouble like wrapping my head around this. But am I understanding correctly that, because at first I thought the keys you were using was something related specifically to JSON, but it's basically the same as a dictionary key, like
Yeah, because dictionary keys are arbitrary. Arbitrary is a fancy way of saying up to the developer, right? It doesn't matter to the Python language what you name the keys. We could name our keys ABC, they just wouldn't add any meaning. But by naming our key payload versus status, we know that payload is what the API is trying to give us, not just its status. And then when we dig into payload, we see that the payload itself is composed of items and then the page results.
Okay,
Yeah.
so at the bottom where you were showing us like the next page, is that almost kind of like when you do, but it basically like gives you the information for the entire dictionary, kind of like when you do like .info, it tells you at the bottom like what the status of that or what the D type is and all of that kind of information.
Yeah, it's a little less sophisticated than that because JSON is language agnostic. So we benefit, being Python users, we benefit from JSON translating one-to-one to dictionaries or to lists of dictionaries.
But I can look at that and see like that information. If I go to the next page, it'll have the same information at the bottom of the page too.
Correct. And so we have our payload of items, and the payload also gives us back paginated results. So here's an example of these last little keys here, right? We get the current page, the max page, and the next page. And notice this next page here, we could do something with that piece of URL. This is not a full and complete piece of the URL. But if we were to tack this next page, that's a string, right? If we were to do, where's the base URL? Check this out. Another request slash, and I'm going to make this an F string so I can add in that variable. This will take a peek at the next page results. Oh, response.json payload. So this is the second page of items. oranges, charcoal, lighter fluid, some sandwich crackers, and then pagination information. So you can see where you currently are, what your last page was, what the next page is, programmatically. It's entirely likely that you may run into APIs that give you hundreds and hundreds of results, basically hundreds of rows of database information, but it's still paginated, so it's not trying to send thousands of results through the wire. And these keys, and I think you asked a really good question, these keys are up to the developer of the API. So I pray that the developer of the API name things nicely and logically, right? Like items, item name, item brand, etc.
Sorry, I have one more question. If you don't mind.
No, I welcome
Further
it.
up, there was something about curly brackets that I was confused about. I'm thinking now it might have just been like the variable that you just did,
This one,
but there was one further up,
these,
like up above. Is that all you've been using the curly brackets for, is just to use it as a variable in the link?
yeah, as part of the F string.
Okay,
I mean, you don't have to use the curly braces with an F string. You could just concatenate with a plus sign pieces of URL. Yeah, what I'm doing with the curly braces here is making the F makes a formatted string, and this means that I'm injecting in that whatever's behind that variable, that print statement into that string.
and you just insert that. That makes, okay, that makes sense.
And that's what I did here. Because as far as like Python itself just thinks this is a string. The only piece of this script that knows that that's anything other than a regular string is the request library. Because when we send the request, it's confirming that this is it's actually an HTTP request. Like if this HTTP was broken or gone, that's just going to blow up, right? And the error message should say since no connection was found, and then it prints out the URL. Imagine trying to put that into your browser. It would break in the same way, right? So I'm going to bring that HTTPS back, and it works. Did that provide some clarity?
Yes. thank you.
Awesome. Folks in the squares, I want to check in with y'all as well. Any questions coming up so far with what we're seeing? All right, groovy. Let's keep going. Now, we're getting a sense that this items key, since it's the value behind that items key is a list, we could use the slicing syntax and look at a slice of options, the first two. We see some sort of beauty bar and some rice, right? And if you haven't worked with this already, you can take a list of dictionaries and turn that into a data frame like that. So if we got our entire items list of dictionaries from the items key, we got the items key from the payload, we got the payload from response.json, we got the response.json from sending a request to that URL, to that API. And we can turn that into a handy dandy little data frame. And just like that, we have rectangular data. Because JSON isn't rectangular, right? It's not rows and columns. But when we take a list of JSON, all of the keys, assuming that all of the key names are the same, we get a column per key name and then a row per dictionary. And so what we're sitting on right here is the first, I know we did a dot head, but if we look at that entire data frame, this is the first 20 items off this API. Not too shabby, huh? So far, we're looking at /items, and there's some other endpoints on this API. There's stores and something else. Stores and sales, okay? So you might start, or actually you will, as you start working with APIs, you'll see APIs break out responsibilities, right? So it's not giving you all the data for everything all the time. You have to specify in the URL if you want items or store info or sales info, right? Let's keep on going. We got a nice little data frame and we have pages. Well, remember that the next page, we can make the next page string that contained part of an endpoint in it. We can use that next page endpoint along with the base URL to get the very next page of results. So when you make a request, it contains in it the seed so that you can get the next page of requests, and that's out of this next page variable. Y'all remember that one? So the code that we're looking at right here sends another request, another separate request to the API, but it's not sending to /items, it's sending to the /items on the appropriate next page. And I'll show you right here what that is. Data, payload, next page. So that's a piece of string. So the first page, the payload for the first page of results has in it the link to the next page of results. Not too crazy, right?
Is that next page string for the request library, or is it?
No, it's a piece of string that came from the API.
From the API?
Yeah, from the API. The request library Python developers didn't write that, Zach did, because it's his API.
Gotcha.
And you'll start seeing question marks in URLs. You probably already do. Like on a YouTube link, it's like YouTube/watch ? And then it gives you the unique identifier for the video. All the question mark means is everything after the question mark is key value pairs in the URL. Yeah. So we get our second page of results, and then we do a pd.concat. We concatenate them all. And now, if we were to take a peek at our data frame is no longer just 20 items, it's 40 items to contain 2 pages of results, right? And there again, our request had the second library, so we reproduce this. So once we made that second response dot, or let's see. Actually, we reassign the data to hold the second page's response. So data, payload, next page, and now our next page is changing to page 3. And so we make a request to page 3, concatenate the results onto our data frame, and then just like that, we've hit 3 pages of items. And it looks like there's maybe like a missing index on this last one, but that's no big deal. What we really care about is the products and their prices and their item numbers and all that good stuff. Okay, I'm gonna check the chat here real quick. Okay, cool. I promise y'all we're gonna do tons and tons and tons of stuff with using the request library to not just get JSON from APIs. We'll use requests to get the pure HTML for a website, then we'll parse that in NLP. That'll be a module in the future. But for now, we're either getting back plain text or we're getting back JSON. And all JSON is a dictionary or a list of dictionaries. And what we demonstrated with this API is it's very common to have dictionaries and dictionaries and dictionaries. We do it all the time. And what's very nice is if we have lists of dictionaries for the things that we're after, we can turn those into data frames. And then once it's in a data frame, that's yours, right? Question?
I don't know if it's just because of this specific website that we're using, but it looked like that we could have prefixes as well, or is it always just suffixes that we're tacking onto the end? Because like in the first website you were showing us with Codeup, that it was API dot. And so
Yeah.
it was in the beginning, whereas this specific website we're using, it's saying put everything on the end. So will
Yeah.
it tell us that if
The docs will tell you.
the docs will
It's one
tell
or the
us if
other.
it goes in the front or the
Yeah,
back?
you usually your different requests and the different URL patterns go on the end.
Okay.
Every so often, it'll be like a subdomain. But the subdomain might be like San Antonio dot Codeup or Houston.codeup or Dallas.codeup or something like that. There's probably a method to the madness.
Okay.
Yeah. The Star Wars API was all appended. Zach's API, it was all appended. GitHub uses not just github.com, but the GitHub API starts with API.
Yeah, that was the one I was thinking of.
www. But it's all pieces of URL. So instead of users, we could look at repos. And check this out. I just imagined that /repos existed as part of the URL, and it doesn't. So we got a not found. And notice the message is the same thing as this, telling you what's going on. And then we could look at an individual user, /username, /individual user. Oh, users, there we go. So I'd encourage you to check out your own, check out yourself on GitHub. You don't even need the request library just to hit an API in the browser. Your browser will kick you back the text or the JSON. It's a nice way of sanity checking yourself. Like if you're having trouble with the Python request library, just fire that URL off in your browser, make sure it's looking good too. So again, this is not, APIs are not specific just to time series, but in these exercises, we'll be using that, that API, that URL. The base URL is python.zgoldie.net/API/v1. And it's either items or stores or sales. And then in your exercises, you can totally do these in a notebook. So you yourself will make a new repository called time series exercises, put that in your Codeup database or Codeup data science exercises folder. You can start these in a notebook, but your end result is we want you to have a nice acquire.py. Okay. And then we'll have you hit the sales API. And then we've also got, let's see, data set countrywide consumption for some power production in Germany. This is a straight CSV. That's actually not an API. That's just a straight CSV. It's pretty cool. It's pretty cool. And this whole JSON thing is a data interchange language. It's really, really popular. 98% of the time, your APIs will talk JSON. 1% of the time it might be text, 1% of the time it might be XML. But there you have it, folks. I hope you found this to build your toolbox. We'll be working on these exercises today. And yeah, I'd love to, on these exercises, I'd love to see some student demos on these. Have y'all walk through some of these for the class when we get there. Class will be over at 3 today. I'm sorry, not 3, at 4 today, because we have our staff meeting. We'll probably start walking through these exercises 3:15, something like that. So I hope you'll have plenty of time to work with these. And then looking into the future, after today, we'll start getting into some more pandas methods just for dealing with time. We have a dedicated lesson on pandas methods for time, because you'll notice there's timestamps in here too. And then we'll get into our data prep, exploration, and then we'll do some forecasting, please.